Tuesday to everyone out there in virtual land. Just so you know, I'm still waiting on a few last week's stuff, some stuff from weeks before that. We're getting towards the end of the unit. Right now I'm looking at next week being the chapter test, or the unit test, I should say. So we should probably be working on getting that stuff turned in and ready to go so that we're all set to go for our unit test next week. Okay? Today we're going to talk about complex numbers. We're going to be talking about complex numbers and using that to find all of the zeros of a polynomial function. So in order to do that, we got to take a moment to go back and let's talk here a little bit about the square root of -8. Now, when I'm taking the square root of a number, I am looking for two numbers that can both multiply together to be -8. So if we said this would be like x times x, okay? Well, the problem is that both of those numbers have to be the same sign, because they have to be the same. 3 o'clock. So when I multiply the same sign together, I can't get negative. Okay? That's the issue. I can't multiply the same number together and get a negative number. So we have to talk about I. Okay? I is the symbol that we use for an imaginary number. The bedrock foundation principle that we're going to use here is the fact that I squared is -1. So then from that, we get the fact that I is the square root of -1. And we're going to utilize that to solve systems of equation, or not systems of equation, excuse me, solve polynomial functions, I think is the best way to say it, to solve polynomial functions for all of their roots. Okay? So what a complex number truly is, a complex number is made up of two parts. Okay? So a complex number has a real part and an imaginary part. The real part is what we could use if we were just writing a real number. Okay? So like 6, the number 6 is 6 plus 0i. It doesn't in complex form. It doesn't have an imaginary part to it. Okay? Or imaginary number would just be 2i. The real part would be 0. But if we combine those two together, then we get what's called a complex number. Okay? So a complex number has both a real part and an imaginary part. We can write any number, real or imaginary, in complex form by filling the other part in with 0. Okay? So today what we're going to be doing is we are going to just be simplifying using I. Okay? So we're just going to look at some radical functions today and simplify them. Tomorrow we'll get into solving using I. Okay? So what I would do here is I would say, well, I would break this out because we know we can't have a negative value inside of our radical. So I would break this out into the square root of -1 times the square root of 49. Now, the square root of -1, that's going to be I. The square root of 49, that's going to be 7. So my answer here, the simplified answer to the square root of -49 is going to be 7i. Today, we're only looking at the principal root of those. Okay? Tomorrow, we will be adding in the plus or minus. But today, because we're just simplifying, we don't have to worry about plus or minus. Okay? The next one is 2 times the square root of negative 32. I would first break that one out. This 2 is going to stay outside. Then this is going to be the square root of negative 1 times the square root of 32. Well, 32 can be broken up into the square root of 16 times the square root of 2. Or the square root of 8 times the square root of 4. And then the square root of 8 could be broken down into the square root of 4 times the square root of 2. So we have many different ways that we can get there. I like to use the biggest perfect square factor of them all. So the 2 is going to stay the 2. The negative 1 is going to become I, or the square root of negative 1 is going to become I. The square root of 16 is going to become 4, and the square root of 2 is just going to be the square root of 2. And all of those are going to be multiplied together to give me, in the end, 8i times the square root of 2. And that is the simplified version of 2 square roots of negative 32. I'll give you a second here to simplify these two. Pause the video, simplify them both, then restart the video, and I will have the answers worked out for you. Square root of 28 is going to be the square root of 4 times the square root of 7. So this 10 stays 10. The square root of negative 1 becomes I. The square root of 4 is 2. And the square root of 7 is the square root of 7. So this one here, or 10 times the square root of 10 times I times 2 times the square root of 7 becomes 20i times the square root of 7. Negative 4 times the square root of negative 75 would become negative 4 times the square root of negative 1 times the square root of 75. The square root of 75 would be the square root of 25 times the square root of 3. Negative 4 is negative 4. Square root of negative 1 is I. Square root of 25 is 5. And the square root of 3 is the square root of 3. So this one ends up being negative 20i times the square root of 3. That is all I've got for you today for I. A quick video here for you. If there were some technical difficulties throughout the course of the video today, I was having SmartBoard issues again, so I had to do some pausing and resetting and all that fun stuff. So I apologize for that. However, this was a good video about I. Tomorrow we'll pick it up in person with talking about solving systems of equations, or solving just equations. Have a great day.